lab on the constant velocity of a moving object. So, as an introduction, the purpose was to measure the velocity of an object moving at a constant speed. For this, I chose a roll of yarn and I pushed it to the left, and that shows the constant speed. And then I also wanted to compare the observed velocity in tracker against the predicted velocity using code. This varies due to non-perfect conditions in the ideal world, such as frictional force and air resistance. And then the key physics behind how this experiment works is Newton's first law for the most part, which states an object will not change its motion unless a net force is applied to it. An example of this is an object will move at a constant velocity unless an external force acts upon it, which is what I assumed is the case for my roll of yarn. And then for this experiment, I assumed, like I said, no forces in the x direction, so assumed a constant velocity. And I also assumed negligible frictional force, air resistance, and that the surface used to roll the object was flat, because if the table was slanted, then the object would accelerate due to the gravitational force. And the key equations behind this, one of them is velocity update formula, which demonstrates in a mathematical way why the velocity is constant. You can see here that the final velocity is the initial velocity plus the net force divided by mass times time. But if the net force in the x direction is 0, then this term cancels out and final velocity equals initial velocity. And the system in this case is the roll of yarn and surroundings, everything else, and there's no net force in the surroundings on the system. And then also position update formula right here demonstrates how I was able to calculate velocity using Tracker, or how Tracker is able to do it, and also how I was able to do it in GlowScript. If you have a change in position over a given period of time, then you know that velocity, the average velocity, and this is how I calculated the velocity. So yeah. And then for the experiment, the initial conditions were an initial velocity in the negative x direction, which I found to be negative 70.94 centimeters per second using Tracker. And the sum of the y forces is 0, and sum of the x forces is 0. And then I said the yarn rolled in front of a meter stick as a point of reference for Tracker. And then I uploaded the video to Tracker to estimate the velocity, and then the initial velocity that Tracker found I used to create a model with GlowScript. And then this is the track. This is the video of me rolling it. I actually rolled it to the right, but when I put it in Tracker, it rolled to the left because the video flipped. So for the purposes of the experiment, I chose to make the direction of the roll of yarn to the left in the negative x direction. And this is a screenshot of what it looked like in Tracker. And then for GlowScript, these are the initial conditions. As you can see, the position I stated to be 0, and the initial velocity vector was negative 7.7094 meters per second, 0, 0, and delta t was the frame rate. And then over here, I changed these based on the velocity update formula and the position update formula. And for this experiment, this doesn't change anything because the net force is 0, so the velocity is constant. And then these are the GlowScript results. As you can see, negative slope, very similar to the results in Tracker, constant velocity, and the ball is moving to the left. And then these are the models compared. As you can see, they're very similar. The orange is the observed, and the linear is predicted using the GlowScript model. And yeah, I'll discuss this more. So an explanation for maybe why the models were similar is because the yarn was moving very fast, which gives the impression of constant speed for a short time period. And then some sources of error I identified was that the speeds diverge at end by a bit, and this is due to forces acting on the object, like air resistance and friction. And it also doesn't account for if the table is level, like I mentioned earlier. And the yarn could also be moving in the z direction, which would cause errors in the distance calculations. And then furthermore, if the axes were flipped, then the yarn would just have a positive velocity. The displacement and the velocity would be the same magnitude but positive. Slope would be positive, and and then I can determine the forces acting on the object vertically, but I cannot determine which forces are acting in the x direction just because